Good evening, guys. So, we are having Arjun over here, who is currently giving his second Anglo attempt. Let's begin. So, Arjun, just introduce yourself.
Sir, my name is Arjun Santosh. I am from Kerala. In my house, I am having my father, mother, and my sister. And I did my engineering from Sri Buddha College of Engineering, Kerala, and I passed out it in 2020 with a percentage of 68%. And I passed out 12th in 2016 with aggregate percentage of 75% and PCM of 69%.
Okay. Why do you want to join Merchant Navy?
Merchant Navy is a glorified career which provides me an opportunity to become an officer in uniform, and also it helps me work with a lot of machineries which I love to do.
Okay. And why Anglo-Eastern? Why only Anglo-Eastern? That is what why you want to join the
Anglo-Eastern,
Navy?
Anglo-Eastern is the most reputed company in India or in Asia, and also it have lot of types of ship such as bulk carrier and oil carrier, etc. So it provides me opportunity to work in different types of ship, and also it provides me a great exposure. That's why
Okay. And what was the percentage
I
that you
can't hear you,
mentioned?
bro. I can't hear you.
Okay, okay, just wait, okay. What was your BTech percentage?
Yeah, 68%,
Okay, and your PCM marks in 12?
67.
Okay. So what are your hobbies?
Hobbies.
Yeah.
My hobbies are reading books, and then playing cricket. That's all.
Okay, so what is the last book that you read? Which one is the last book that you read?
Last book was a fictional book, which its name was Feluda Stories, and it was written by Sajid Roy.
Okay. So let's begin with the technical part. Draw and explain me the centrifugal pump and explain
Okay.
how it works.
Okay. So can you see?
Yes, yes. The impeller should be like uh,
I can't hear you,
okay,
bro.
yeah, yeah. Your impeller should be like it should be gradually increasing, not this much of gap between the casing and the impeller. It should be minute, okay? Not very large as also. Wait, I'll show you, okay? I'll show you.
Okay.
I'll draw and
Yeah.
show you. Wait, 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 wait. I'll have to turn off my this. Yeah, explain me the centrifugal pump.
Okay. Uh, when we switch on the centrifugal pump, the impeller starts rotating. So, since there is water is already present inside the casing of the pump, as the impeller rotates, it will discharge radially towards the discharge side of the pump. So, a vacuum space will be created around the eye of the impeller. So, we know that water flow from high pressure region to low pressure region. So, water from the sump flows through the suction pipe of the centrifugal pump through the foot valve and the strainer, and reaches the eye of the impeller. At the impeller, since impeller is rotating, a centrifugal force is induced on the fluid, and it it exits out from the impeller and flows through the volute casing towards the discharge side of the pump. The volute casing of the centrifugal pump is designed in such a way that its volume is increasing towards the discharge side of the pump. So we know that according to equation of continuity, A1 V1 is equal to A2 V2. So since the volume is increasing as the discharge side of the pump, the kinetic energy is reducing and the pressure energy is
Yeah, you should
increased.
mention velocity decreases. Okay.
Oh,
Since
velocity.
you are mentioning area and velocity, right?
Yes, yes.
A1 is area and V is velocity volume. So as volume increases, the sorry, yeah,
Volume is
uh,
increasing, velocity is decreasing,
yeah, yeah,
and
yeah.
pressure energy is increasing.
Yeah, yeah. A is the cross-sectional area actually.
Okay.
Equation of continuity, A is the cross-sectional area. As the cross-sectional area increases, so velocity will decrease. So after that, go on, move on. After velocity decreases, then
As velocity decreases, the pressure energy increases.
okay. How does
According
it?
to
How does it
Bernoulli's
happen? Okay, okay.
principle, the pressure energy increases.
Okay. So as you mentioned, you should say as at the discharge side, as volume increases, so the velocity decreases. So this drop in velocity causes kinetic energy to decrease, as velocity is directly proportional to kinetic energy. So kinetic energy decreases of the fluid. So as per Bernoulli's theorem, the drop in the lowering of the kinetic energy gets converted into pressure energy as per Bernoulli's equation, and this is how discharge pressure is created in a discharge side of the centrifugal pump. Okay,
Okay.
rest was good. So let's go on. What is priming in a centrifugal pump?
Uh, Priming is the process of removing air from the centrifugal pump.
Okay, it's only removing air.
Yeah, removing air from the centrifugal pump.
Yeah, it's removing of air and charging it with the same liquid to be pumped. Okay, with
Ah,
the
yes,
process.
okay.
Okay, you just not remove air, you also fill it with the liquid to be pumped, because how centrifugal pump works is it should have some fluid now.
Yes, yes,
Only if it displaces, then only a void will be created. Correct. So
yes.
only drawing out air doesn't mean your priming is done. It's all removing of air, also filling the liquid up to some part of the discharge, and so that is what is priming. So why do we do priming in a centrifugal pump?
Yeah, if you do not do priming in a centrifugal pump, then air may enter into the centrifugal pump. We know that water is incompressible, but air is compressible. So that since air is compressible, the centrifugal as the impeller rotates, it will compresses the air, and also the density of the air is 1,000 times lesser than that of the water. So the centrifugal force developed inside the pump is also much lower. So the suction pressure developed inside the centrifugal pump will be also be lower. So the pump will be running at dry condition, which can affect the damage to the motor windings and causes overheating inside the pump.
Okay, it was okay, but only thing you have to mention is that density part. Density of air is 1,000 times less than density of water. So centrifugal force, which is mass times omega square times r, correct na? Centrifugal force is m omega square r. So
Yes,
if mass is 1,000 times less, means centrifugal force will also be 1,000 times less. So this relation you have to show, and also you have to show that centrifugal force imparted by the impeller onto the air will be 1,000 times less. Okay, if water is there, it will be 1,000 times more than air. You have to compare like
yes.
this. Okay, just say the density of air is 1,000 times, as density of air is 1,000 times less than water, so centrifugal force, which is m omega square r, will also be 1,000
Thousand times.
times less. So the centrifugal force imparted by the impeller onto the air will be 1,000 times less if water could have been there. So that causes motor to run dry. Okay, and the suction capacity also, the discharge pressure also doesn't get created. This is, and also efficiency of the pump reduces. Okay,
Okay.
rest of it was good. So explain me the VCRS system.
And the VCRS system consists of compressor, condenser, thermostatic expansion valve, evaporator. So, in a VCR system, uh, the saturated vapor, which is having low pressure and low temperature, is isentropically compressed to uh, s- isentropically compressed to superheated vapor. refrigerant having high pressure and high temperature. This superheated vapor refrigerant, which is having high pressure and high temperature, is isobarically condensed to saturated liquid refrigerant, which is having slightly lower temperature and high pressure. This saturated liquid refrigerant is passed through dryer in order to remove the moisture from the refrigerant. This dryer consists of silica gel which absorbs the moisture from the refrigerant. Then this saturated liquid refrigerant, which is having low temperature and high pressure, is passed through thermostatic expansion valve, which in thermostatic expansion valve, it will undergo isenthalpic expansion. Thus, saturated liquid pressed vapor refrigerant having low temperature and low pressure will be produced at the discharge side of the thermostatic expansion valve. Then this saturated liquid vapor refrigerant, which is having low temperature and low pressure, will pass through the evaporator where it absorbs the heat from the region to be refrigerated and gets evaporated to uh, vapor refrigerant, which is having high temperature and high pressure. And it is again passed through the compressor for the next cycle.
So you should not mention the vapor is high pressure, high temperature. Okay, it is the same line. If you see TS plot, na, you have the TS plot, na?
TSTC.
Yeah, yeah.
Uh,
At the point exit of the thermostatic expansion, you seen the point exit of the thermostatic expansion valve TEV.
yes, yes.
Yeah,
Uh,
it's a straight line, na?
straight line.
So you said low pressure, low temperature, it gets into low pressure, low temperature, liquid vapor mixture, correct? And then after the evaporator, you are saying it gets converted into vapor, high pressure, high temperature. So is
Okay.
it not the same line?
Yes, yes, yeah. Oh, okay, okay. It's same line.
It's same
Isobaric.
line. So it's a isobaric. So you can't say high pressure, high temperature. Just
Okay.
say it gets converted into vapor. Okay, vapor.
Saturated.
Yeah, not saturated. You can also yeah. Okay, saturated vapor. Okay, also good. Saturated vapor, and that saturated again goes into the compressor, and the cycle repeats. Okay,
Okay. And
okay,
then sensing bulb is provided at the discharge side of the evaporator, which is connected to the thermostatic expansion valve with the help of a capillary tube. Yeah, so the sensing bulb will measure the temperature of the refrigerant at the discharge side of the evaporator. If it is more than the desired value, then it will send signal to the thermostatic expansion valve to allow more refrigerant to flow into the evaporator by opening the orifice of the thermostatic expansion valve more. If the desired temperature, if the temperature at the discharge side of the evaporator is less than the desired temperature, then the orifice of the thermostatic expansion valve will close more.
okay. And what is the signal you said? What kind of signal is sent to the thermostatic expansion valve? You
Um,
said signal is sent, na?
yes, yes.
Okay, not no.
No, no, no.
Okay, so what happens now? At the exit, you said exit of the evaporator, you have sensing bulb, correct?
Yes, yes.
And then it is connected to the thermostatic expansion via capillary tube. So
Yes, yes.
actually in the capillary tube you have refrigerant. Okay,
Okay, okay.
no signal and all. We have a refrigerant inside the capillary tube. So let's say at the exit of the evaporator, temperature is more than the desired. So it will cause expansion of the refrigerant inside the capillary tube. Okay, okay, it will cause the expansion. Makes sense, na? So that will act on the thermostatic expansion valve. Now at the thermostatic expansion valve, we have a diaphragm. It's like a plate loaded with a spring, okay, spring and a screw, okay. Up is the diaphragm, which is a plate kind of in the thermostatic expansion. Then we have a spring after that, and then a screw. So the screw is actually inside the path, okay. It's in the path between the thermostatic expansion valve to the evaporator. How it flows, na? It has a path. Now you said contact expand, so it's a path. What happens is, as the desired temperature is more, it causes the this refrigerant inside the capillary tube to expand. It acts on the diaphragm of the thermostatic expansion valve. This compresses the diaphragm down because it is spring, na? Hello. Can you hear? Okay. So as I told you, you have a diaphragm. Let's say this is the diaphragm, and then you have the, let's say temperature is high at the exit of the evaporator. So to
Okay.
the capillary tube, since refrigerant is at high temperature, it will expand. It will act pressure on the diaphragm, which will cause a spring which is downwards to act downwards. Okay,
Okay.
so it has a screw downwards, so more flow of refrigerant will take place. Likewise, if the temperature is low at the exit of the evaporator, means the room is already cooled. Okay,
Yeah.
so you don't want
Yes.
more flow of refrigerant to take place. So as per the spring force, now you're compressing the spring. So as the refrigerant doesn't expand, it will not act on the diaphragm. So as per the spring force, it will cause the diaphragm to move upwards. Okay, because of the spring force, and so the as per the set value, it will restrict it. Okay, so this
Okay.
is how the sensing bulb and this. There is no signal as such, but you can say
Okay.
signal. Don't mention this thing, okay, to him. Just be ready. If you say what kind of signal, be ready, okay. So people have mentioned this only. They have cleared it. So you don't mention this thing. Only for your extra knowledge, I mentioned this. Okay. Let's move ahead. Uh, then we move on to no the diagram, na VCRS diagram.
Yes. Yeah.
Yeah, no, okay, that's fine. Uh, What is the temperature of the refrigerant at the exit? What is the temperature of the domestic refrigerator?
It depends upon the refrigerant we use.
Okay. So what is the temperature for R134A?
Uh, Around minus 18 to minus 20 degrees.
Okay. And what are the reefer safeties?
Refrigeration safeties consist of low pressure cutout, high pressure cutout, lube oil low pressure cutout, uh, liquid shock valve on compressor, bursting disc, and then relief valve on condenser, master solenoid valve, oil heater. mm,
Enough. These many are good to go. Okay. What did you mention about after low low boil pressure? This thing cut off. We mentioned some safety, na?
Bursting disc.
Bursting disk. Okay, okay. Bursting disk.
Yes.
Okay, okay. You should either mention bursting disk or relief valve. Purpose is the same.
Okay.
Okay. Either mention relief valve is good, should be good. We have
Okay.
on the Ashish PDF it is relief valve. Both are mentioned on his PDF.
Both are
Both.
both are mentioned.
Okay, okay. Then mention both of them. Okay.
Yes.
So all of that. Why do you require oil heater? You mentioned oil heater.
Yes, yes, I
Yeah,
mentioned.
why you require oil heater?
Oil heater is required to heat the lube oil inside the compressor since it is only the component in the VCR cycle which have uh, rotary parts.
No, why does
The
you require oil heater? Why not oil heater in the air compressor in the crankcase part?
oil heater in the
Crankcase of a air compressor. Why only oil heater in a VCRS compressor? Compressor will also have a connecting rod and the crankcase, na, where oil is
yes, yes,
there. So
yes.
why you require only oil heater and why not in the air compressor?
Oil heater is provided in order to avoid the overcooling of the compressor, which will affect the movement of the particles since due to low lube oil pressure. So in order to keep it heat,
See,
we use oil heat.
VCRS means cooling, correct, na?
Yes. Yes.
VCRS means cooling, so there are chances of compressor getting cold. So you know
Yes.
what happens when oil gets cold? What happens
Oil
when oil what happens when oil gets cold? So you have oil actually in a cold environment, meaning a compressor which can have a cold environment. So it forms high viscosity. So it
uh,
viscosity of the oil increases. This
Yes.
hinders the lubrication part of it. Okay, so that's why oil heater is required. This is general extra knowledge. Okay, it won't be asked. Just I'm asking
Okay.
you. So it makes sense now. Oil heater in this means viscosity will increase. You see in coconut oil now what happens in the winter and all
Okay.
some
So I have a doubt. Oil heater is used in compressor itself, right?
yeah no I think in the crankcase to heat the crankcase not in the compressor. Oil heater na oil will be will be present only in the crankcase na like a IC engine it will have a piston connecting rod the other crank web crankshaft so crankshaft will be connected to a motor got it na so you
Okay.
need lubrication of the bearings and the crankshaft na since it's rotating
Okay.
so that oil can get cold because of the refrigerant so minus 18 you said na you can imagine minus 18 minus 20 how cold it will be so it's in oil, na? It will increase in viscosity. Will cause viscosity increase can cause hinder the lubrication part. Okay,
Okay.
lubrication won't be effective as such. Okay, so you have an oil heater which heats the oil, so viscosity decreases and good lubrication takes place. Okay, got it, na? This is
Good.
just
Good.
an extra knowledge. It doesn't ask this.
Okay.
Let's move on. List the boiler mountings.
Okay. Boiler mountings consist of safety bar, gauge glass, feed check bar, scum down bar, blow down bar, low water level shutdown, um, vent coke, then fusible plug, um, steam stove bar. Um, yeah, that's
Boiler feed valve, you said.
what?
Boiler feed valve. Feed valve. Feed check
Feed
valve.
check valve. Feed check
Yeah, yeah,
valve.
okay,
Yes,
okay,
yes.
sorry,
Fusion.
feed check valve. Okay, okay. So explain me the fusible plug.
Okay. Fusible plug is a hollow tapered cylinder which is made up of brass, bronze, or gunmetal. And the hollow part of this is filled with a fusible material, which is generally tin or lead alloy. So, when the fusible plug is subjected to higher temperature, this fusible material will melt and the higher pressure developed inside the system will vent out through this hollow channel.
Okay. So where it is present? Where exactly is it present?
In boiler, it is present above the combustion chamber.
Okay. Okay. To be
So,
more concise, you can say, for example, for a water tube boiler, there is steam
okay.
drum and a water drum, no?
Yes.
So it is present in the steam drum. It's
Mm.
at the bottom of the steam drum where the combustion chamber, close to the combustion chamber. So what happens is at a certain point when the water drops in the steam drum, it could be hazardous. So what happens is steam which is there, which is at high pressure, high temperature, acts on this fusible metal which is there of the hollow part, and then it melts let's say at tin or lead at 232 or around 230 degrees Celsius. It will
32
melt.
degrees Celsius.
Yeah, it will melt, and the high pressure will blow off the fire in the furnace. So this is how fusible plug works. Okay, just mention the construction how a fusible plug is, then you can say an example in case of water tube boiler, mention water drum,
I
steam
have a
drum.
doubt.
Yeah,
In compressor also fusible plug is used, right?
fusible plug, yeah, yeah, in the compressor also, but it is
So
present at the air bottle where you store air
air
now.
bottle. Okay.
Okay, so there now I'll ask you why is fusible plug needed in a air compressor, as you mentioned about air compressor, so why is it required? Yeah, you got now because fusible plug is required because if you
Okay.
don't have the pressure, it can explode.
Yes, sir.
The tank can explode. So why
Uh,
you require in a air compressor or fusible plug?
so because in order to avoid the over pressurization inside the air bottle
So
of the
fusible
compressor.
plug works on the. You can have a relief valve on the air bottle. Why only a fusible plug? Fusible plug will melt only at high temperature. So why is there requirement of a fusible plug? As you know, there is bursting disc on a air compressor. Also, there is a
Yeah.
relief valve for high pressure, as you said. Why only? So why a fusible plug?
I don't.
So it's because you can have this thing, oil that is carried, okay? Lubrication of air compressor is required, na?
Yes, yes. Yeah.
Yeah, oil in the crankcase of the air compressor. You have two compressors. You can see my video.
Yes. No. Now it is stuck.
Okay, now.
Yes. Now I can see. Yeah.
Okay, so you have two compressors, now.
Oh,
So there are chances of oil carryover in the compressor. Okay,
okay.
since
Okay.
there can be oil going, na. As in IC engine, there can be also air going. Wait, on my charging is less. Wait, 1 second.
Okay. Okay.
Yeah. So there can be oil carryover. Okay,
Okay.
compressing there can be air going. So this oil going oil going into the air bottle and high pressure means it can cause explosion. Okay,
Okay.
oil in
Okay.
at high pressure, since it's compressed, temperature also increases, it cause explosion in the air bottle where it is stored. So due to
Okay.
this there is a fusible plug. In case it goes to that limit, let's say 232 or 230 as per T all that, it will melt and it will this vent out the air which is present in the air bottle. Otherwise it can be this na hazardous. Since you
Okay.
are pressurized air you are storing in the air bottle means
Yes.
temperature
Yes.
also increases. As
Temperature
per
also.
temperature also increases. So if oil is carried, oil gets carried along, they can be hazardous. Okay, it's completely fire triangle. Since temperature is there, the combustible material is there, also air is there. So these three this
Fire
what you say,
triangle.
yeah,
Fire
fire
triangle.
triangle gets complete. There can be explosion. So to prevent this, when temperature is high, causes the fusible plug to melt. So it is vented out. Okay, got it now.
Got it. Got it.
Okay, and okay, what is bursting disk and where it is present?
Bursting disk is present at the intercooler and aftercooler of the compressor. Um, Bursting disk is a non-reclosing device which burst out in a controlled manner. Bursting disk is a non-reclosing device which bursts in a controlled manner when the pressure inside the system reaches a predetermined point, and it will burst out and release excess pressure from the system.
Okay, where is it present in the air
It is
compressor?
present. It is present in the intercooler and aftercooler of the compressor.
Which side? The water side or the air side?
It is present at the air side,
No, it's present the water side.
water side.
Okay, what happens now? There is a box kind of. Intercooler is
Uh,
actually a box. Okay, and you
okay.
have these tubes going. It's like basically a heat exchanger. Okay,
Heat exchanger.
basically
Okay.
a heat exchanger. So you have tubes which carry air from the first compressor to the second compressor. I'm talking about the intercooler. Okay,
Okay. Okay.
okay. So you have tubes which have air inside it, which is having pressure of about let's say about 23 to 30 bars. Okay, this much high
Okay.
pressure, and you have water which is circulated to cool the air which
Air.
is there. Okay,
Okay.
so that water is hardly around 2 bars or 5 bars, let's say 5 bars, 2 bars, and
Okay.
the intercooler is actually made out of cast iron or such metals. So what happens is, let's say there is leak in the tubes inside the intercooler. So
Okay.
30
Okay.
bar pressure means you can crank the engine. You can imagine the power, right? You can
Ah,
crank
yes.
the engine, it can reverse the engine, you can this. So this much power, or meaning this much pressure, 23 30 bars. So this can cause the water which is at 5 bars
Ah,
to
okay.
just flash, okay, from the air to the water, okay, and this can cause like bullets, you can see, imagine bullets na of the cast iron. It can impinge on, like, if a
Okay, okay.
person is standing in front of the intercooler, it can the particles can just go inside his face or whatever part. So it can be hazardous. So what is busting disc does is, it is present at the water side of the intercooler, okay. Let's say
Water
there
side
is,
or air side?
no, water side,
Okay,
okay,
water side.
water side. Let's say there is this thing, you can't this na it should be present at the water side, because let's say the tubes inside get just leak, the pressure gets leaked, okay, air gets leaked, which is high pressure. So it will cause the water to, it will act inside the chamber and will cause the busting disc to open, and that's how the water will be safely drained, okay.
Okay, okay.
You can't have a bursting disc on the tubes. So what will happen, this will automatically at 23 or 30 bar it will explode na, the bursting
Okay,
disc
okay.
will rupture na, it will cause the cast iron of the intercooler also to rupture then, okay. So
Okay.
you have it on the water side, okay,
Okay, water side.
water side. This is the valid answer, I know it properly, okay, that's why I'm telling
Okay,
you,
okay. Okay,
okay.
okay.
And lastly I will ask you, what are your strengths and weaknesses?
What are?
Your strengths and weaknesses.
Okay. My strengths are time management, then leadership qualities. Because I was the cricket team captain of my college team, so I have an experience in leading a team, and we won a lot of tournaments. So leadership quality is one of my strengths, and my weakness is I believe everyone easily, so which may sometimes had a negative impact on me because uh, some of my friends had cheated me. That's my weakness.
Okay, I missed on some electrical parts, so I'll ask you now. So,
Okay.
what is Lenz law?
Lens law.
Yeah, Lenz law.
Lens law. Lens law state that the direction of the induced EMF in a system is uh, in such a way that it always tends to oppose the reason for causing it.
Okay, oppose the last part. What did you say?
A reason for causing it opposes the reason for
The
causing the
direction of
induced.
induced EMF is always oppose the cause that produces it. The cause is the magnetic
Yes,
flux, na? The direction of
yes,
induced EMF is such that it tries to oppose the cause that produced it. Okay.
yes,
Cause
yes.
is the magnetic flux, actually. You can mention also magnetic flux. That
Okay,
cause,
magnet.
what causes it to induce current is actually the magnetic flux, na?
Magnet for sure.
Yeah, so you should say mention like that, okay. So let's close down for the day. So at last I will ask you, for the, it's for the audience whoever are watching this. So what made you not clear at the first attempt at Anglo?
At the first attempt at the Anglo, I explained in a gear pump, and then the cancer sir asked me about how pressure is created at the discharge side of the pump.
Okay.
Uh, and during that time, I had no idea about it.
Okay, okay.
Uh, so I was not able to explain him that.
So that was the only question that you did not answer.
Also, he asked me about the fusible plug. When I mentioned him about the compressor safeties, which you
Okay.
explained me right now.
Okay.
So I had
Oh,
no idea about that and these two questions.
okay, okay. And this man, and what he said at the last 10? After that, I'm not selecting you. What he say? What did he say at last?
Okay, Arjun, your interview is over. You are not selected.
Okay,
That's it.
okay, okay, got it. Okay. So let's close down for the day. So this is AMSTON signing off.